Okay, let's work this question here. What we have is we have a long straight wire that we are looking at from the top here. And that's what we see. So we see an X representing the direction of flow of the current. It means that the current is going perpendicular to the screen into the screen. Now, the question asks us to find the direction of the magnetic field at point P1. The next question at point P2. I'm going to do both of them at the same time. Now, using the right-hand rule, our thumb should be in the direction of the current. In other words, our thumb should be pointing towards the screen, into the screen. Now, when we wrap our hand, our fingers are going to be wrapped around the wire. So this is where our nail is. And this is the beginning of our fingers. It is wrapped around the wire. Our thumb is pointing towards the screen. So as you notice from this, the magnetic field at point P1 should be in this direction. The magnetic field at point P2 should be in this direction, continuing the wrapping. Okay, so for P1, it should be towards the bottom of the page. That's what we have there. Now for P2, it should be towards the left side of the page. Now, this is another question asking about the same concept. In this case, we have a long straight overhead conductor that's carrying a current from north towards the south. So if this is my north and this is my south and this is the wire, the current is going from north towards south. So this is the direction of the current. Now we are standing directly below the wire. This is where the person is standing. The direction of the magnetic field here, where the head is going to be in what direction? Again, we wrap the fingers around the wire. The thumb is in the direction of the current. The fingers, using the right hand, are going to be like this. This is the nail. So when you do that, that shows that the magnetic field on top of the wire is pointing perpendicular to the screen and into the screen. However, below the wire, it's going to be perpendicular to the screen, out of the screen. Now, out of the screen, what's that going to be as a direction? If my north is here, now my east is going to be in this direction, and my west is going to be in this direction. So the magnetic field where my head is going to be towards the east. Now, let's consider this other question. We have a magnetic field that's uniform over a large volume of space, directed perpendicular to and into the page. So we have a region of space, a big region of space, where I have a magnetic field that's pointing this way. And so on. I can keep putting X's. It's the same throughout that region. It's perpendicular to the page and into the page. And the question here says, we have an electron entering this region, initially moving along a line parallel to the top of the page from left towards right. So this is the way initially the electron is moving. The question is, what would be the direction of the force that the electron is going to experience once it enters this area? Now, to do that, we are going to again use the right-hand rule, but our thumb in this case is going to be opposite to the direction of the velocity. So if I'm going to do the right-hand rule, this is the direction of our thumb. Now, fingers are going to be in the direction of the magnetic field, so they are going to be pointing this way into the screen, and our palm is going to point then downwards. So my force is going to be towards the bottom edge of the paper, or the screen in this case. Now, this question here is showing three pictures of a magnet and magnetic field lines, and it's asking which one is the correct one. One thing we need to remember, it's always pointing away from the north. We have all of them, the magnetic field lines are pointing away from the north and towards the south. So that part is fine. So we have to focus on what else happens. In this one, we see the magnetic field lines originating at the poles and stopping inside. And that's a distinction that magnetic field lines have from electric field lines. They are continuous. So this is right. This is wrong. This cannot be right. Now, both of these figures show magnetic field lines within the magnet. However, in this one, they are reversed, while in this one, they are continuous. So this one is the correct answer. The magnetic field lines are continuous. They do not flip anywhere. So that should be the correct answer.